Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see how we can do hyperparameter tuning and do cross-validation using SVM kernels. So in the previous video, I have already described what is SVM kernel, and we have also done the implementation part of SVM kernel, in my previous videos. So in this particular video, let's see how we can tune the hyperparameter and implement cross-validations in SVM kernels. So before moving ahead, I do recommend all of you guys to subscribe to my channel and as well as connect with me on LinkedIn. So let's move ahead. So when you talk about cross validation in SVM, right? So if you see over here, these are almost same libraries that I have imported even during when I was explaining you SVM, right? So first of all, I have imported NumPy. Then from sklearn, I have imported datasets because I would be using a dataset, right? Now similarly, I have also imported SVM because I'm using SVM. From model selection, I have used cross val score, right? Because we are going to do cross validation. So let me simply run this. Now, if you see in the second command, while the first one is running, x comma y is nothing but my training and test data set. Now this data set, how I'm getting it from the data sets that I've imported at the top. Data sets.load digits. This is what I am getting as my input data set. Now this is a pretty clean data set. If you want to understand more about this, you can simply say, the data set, basically you can simply do the description .describe. You can use to understand more details about this particular data set, but this is a pretty clean data set which is giving me both my training as well as testing data set, right? Now SVC, now this is my support vector classifier. Now if you see SVM, right, so I'm using support vector machine over here. I'm using svm.svc. now it is exactly same that I am using that I've used in my previous video as well when I explained you SVM, right? svm.svc. From here, from this particular svm.svc, I am using the kernel of linear, right? We have already seen what are kernels, what is a linear kernel, what is RBF and everything, right? So I'm using linear kernel from SVC. So basically here the main idea is, so from SVM, I want to use linear kernel. Now, if you see here, I have also coefficient C, right? I also have something called as coefficient C, which is nothing but my regularization parameter, right? Now C is nothing since I'm using linear SVM, right? So basically I will be using regularization parameter over here, because here basically I have to simply get my y is equals to mx plus c, right? Now here I have given this is my hyperparameter, which is nothing but my regularization parameter, and I am deriving few values for it, right, on which I will do cross validation and I will try to get the best fit for my model. So if you see the CS, right, I'm using log space -10, 20 and 10. So basically it is going to give me, let me simply run this and let me try to print the value of C. Let me check where the name n is not defined. Okay, so it was just a normal mistake, and now you can actually see I have also run print CS statement. Now if you can actually see what has happened is I have got 10 values, right? I have got 10 values with the difference of log, right? So that is what log space is doing. It has given me 10 values, right, over here. So I have got, for the regularization parameter, I have given some set of values. I have given some set of 10 values. Now using these 10 values, I will try to train my model, okay, and then I will try to get the best fit value of CS, the best fit value of the regularization parameter for my model. So now in the next command 4, you can see what I'm saying is for C in CS, I'm using a for loop for C in CS. CS is nothing but this. So for each value which is present in my CS, what is going to happen? My cross val score is going to run. My cross validation is going to run. My cross validation is actually going to run on SVC that I have created. This is the model that we have created, and this will be my training data set. Y will be my testing data set. N jobs is nothing but number of jobs that run in parallel. So we have already discussed about cross validation, right, in my previous video. So what we basically do in cross validation, we basically divide the data set and then we try to, usually we do k-fold cross validation, right? So if you see over here, what we do, this is our data set. So we divide our data set into training and the validation set, right? And then for each of these, what happens is iteration 1 2 3 4 5, what is this? This is nothing but number of folds, right? So for the number of folds, whatever error we get in the each iteration, right, we try to get the mean value of it. So this was nothing but, this is already I have explained in my previous video, so I'm not going to go in much detail over here, but that is what your cross validation is about, right? So here, since I have not provided any value for my fold, right, so by default it is going to take 5 as my default it was going to take my 5-fold cross validation. So for my 5-fold cross validation, basically what is going to happen, it is going to do 5 iteration. Now each of these iteration it is going to do sequentially, it is not going to do it in parallel, because I have mentioned here as n jobs equal to 1. So number of jobs that can actually run in parallel, that is nothing but n jobs over here. And the moment this is done, what I'm trying to do, I'm trying to get the mean as well as the standard deviation, right? I'm trying to get the mean and the standard deviation. So let me simply run this. Now once I run this, you will actually see what I'm trying to do. I'm trying to plot these values, I'm trying to plot these scores SCS, I'm trying to plot these scores with the parameter. I'm trying to get cross validation score with the parameter C that we have given as an input. So for each value of input, how does my score looks like, how does my CV score looks like, right? That is what I'm trying to get over here. So if you see over here, what I'm trying to do, just check over here, I have imported my matplotlib library because I'm using this to plot, right? And then you can actually see I am just plotting my cross validation score and my parameter C. Now the moment I have done this, you know what should be our target? If you have watched my previous video, you already know that your target should always be to maximize the value of cross validation score, right? Now if you see over here at this particular value, you can actually see your at 10 to the power minus 4, right? Your cross validation score is high. After that it is pretty much becoming almost constant, right? Your cross validation score. So what we will do is now we know that, okay, using this graph I already know that, okay, this is my best parameter 10 to the power minus 4. So now what I'm going to do, I am going to say svm.svc. I am trying to create a model over here. The model is linear and the value of C, now I am passing it over here. Now I am saying the value of my regularization parameter is 10 to the power minus 4.0001, and using this again I am trying to do cross validation, right? Now earlier, remember that earlier cross validation was happening with the for loop, right, for the multiple values. Right now the cross validation is happening for this particular value of C, because I have said that get me the model which will be my best model. Now I know that my best model will be with this regularization parameter. So now I get my best model, right? Now I have also got the score of this model right now, and then I'm going to print the score of this particular model. Now these are the multiple scores, right? Because it is a 5-fold cross validation, right? That is going to happen, right? Here I have not defined any folds. So automatically it will be 5-fold cross validation. So you can see 1, 2, 3, 4 and 5 values are there. And if I get the mean, if I want to get the mean of this, you can actually see I have this 93% accuracy. So you can see the mean is 0.93. So this model is a pretty much good model with 93% accuracy. Now remember that let's say if I increase a 0, right? So let's say if I choose 10 to the power minus 5 over here and again I run it. So let's see will my accuracy, how my accuracy would be. So now let's run command 7 and let's run command 8. Right now you can see the accuracy has decreased, right? It has become 75, right? Now even let me increase one more 0 and let's see how does my accuracy looks like. I have run till command 8 and now you can see with 10 to the power minus if you see 1, 2, 3, 4, 5, 6, right? So with this you can actually see that my mean has become 0.15. So the accuracy has even got lowered, right? So this is how it actually works. You can actually see you got the best model with 10 to the power minus 4, which we also saw diagrammatically. Now this was a linear model, right? So if I want to run this model with RBF, right, with RBF kernel, you can run that. Now once we run that, we will actually see that whether RBF is good for it or our linear kernel was good for this particular data set. So you can see the same thing, right? svm.svc kernel is RBF and gamma value I'm providing it as 10. So you already know, right, that in RBF we have already discussed. So let me even show you again. So in the RBF, this is the formula for your RBF, right? So you don't need to memorize your formula, but you need to understand that gamma is required in all three of them, right? So, and in RBF you only need gamma, right? Gamma is a multiplier, so it increases the value, magnitude of your value, right? So gamma is the hyperparameter over here. So if I go back, you can see that I have provided the value of gamma as 10 over here. Now again, if I want to run this, you know, I'll get some model which will be based on RBF over here. Now if I try to print the score, right, now you can see these are the scores, and if I try to get the mean of the score, right, the mean is 0.1, so basically 10% accuracy. So here we can actually say that this model is best suited for the linear kernel only. So this is how we basically, you know, use cross validation to tune our hyperparameter in SVM. So I hope you like this particular video. Do remember to like, share and subscribe to my channel, and keep watching these videos, because you know, if you are already part of a data engineering domain, it is very helpful to learn data science. And if you are fresher and you want to learn data science, then also these videos are really helpful. So thank you so much for being till here, and do remember to like, share and subscribe to my channel. Thank you so much.